we've got two cars. They're going to collide with each other at 80 kilometers per hour. Now, the first thing you got to realize is all they have are kinetic energy because they're on a flat plane, these railroad cars, and they're going to collide with each other. And they're moving at 80 kilometers per hour. So they've got kinetic energy, which is 1/2 mv squared. Now, warning, the v is in kilometers per hour. You have to convert it to meters per second. So that's going to be a bit of a conversion. And if they collide with each other head on, their total energy would be additive. So it's the same kinetic energies, they have the same mass, and if they have the same mass, what did I do wrong? If they have the same mass, then you can double it. So it's really, so it's going to be the kinetic energy times 2. So 2 of these, which is just mv squared, I guess. So you're going to find the total energy, and then that's it. I guess that's how much is, if they stop each other, that thermal energy will be just double of 1/2 mv squared. Now, letter B, if you took like honors chemistry or whatever, then this question might make a role. There's the equation for heat. No, it didn't say here. Yeah, it is Q. Sometimes we use the thermal energy. It's just called Q. That's the thermal energy. We've been using E thermal, but it's the same thing. That's just equal to mc delta T. And the question is, what mass? So once you know this number from part A, you're going to set that equal to m times c times delta T, and you're going to solve for N. The C is given as this 4128 number. The change in temperature is from 0 to 100 degrees Celsius, so that's 100 degrees. You're going to solve for M. As a side note, it's not a very big number, so don't panic if you don't see a big number. That's how you do it.